Hello, how y'all doing today? My name is Bernie Thompson, and today we're going to take a look at this 2017 GMC Yukon. This Yukon is having a communication failure with the frontal camera, the camera that's the center mount one in the windshield. So what we need to do is we need to gather some data. So we need a scan tool, and we need to look at data through the scan tool. So let's go ahead and get into the system and see what's going on with this Yukon. On this COM problem, we're going to be working on this vehicle where the engine may or may not be running. And I don't know what it's going to take, so I'm going to go ahead and I'm going to put a battery charger on this to make sure that our battery voltage stays high enough to where we don't have any problems from the battery going low. Now we have our scan tool connected to this GMC Yukon. We have a GMMDI scan tool connected, and basically the first thing that I want to do is I want to run the DTCs for all the modules on the car. So that's what we're going to do. We're going to gather some data, and we're going to see what modules have any diagnostic codes and what those diagnostic codes might mean to us for what we're trying to diagnose. Where we see these red blocks, that means that we can't communicate with that module. But like this car is a rear-wheel drive, so we don't have four-wheel drive. There's no transfer case module. So I'm not really worried about that at this time. So the one thing that we do need to do is, now that we've got the data, we want to go to details. And that will give us our DTCs. Now that we have our DTCs, we can see that we have a keyless entry code, a parking assist on the rear sensor that's on the bumper. The ignition on-off circuit source bypass relay has something. The keyless entry system transmitter has a low battery. Lost communications with the vehicle directional camera. Now that's one of the codes that we're here looking at. And that's being set by the cluster, the instrument cluster. So now we also have a passenger airbag indicator circuit, a passenger airbag off indicator circuit. We have a LIN bus, and that LIN bus is being set for the radio control. So it's saying that we have something there. And that also has to do with communication, so I'm really interested in that. Liftgate module switch circuit, and we've lost communications with the electronic brake control, and again, that's from the frontal camera. So basically, we have several codes for the camera, and we have a LIN bus code. So those are all going to be important. We need to keep those in mind. Now on the codes, there's something else I want to look at that's very important. When you come over here and you look at your status on the DTCs, this is the status that's current. Well, it says that on this lost communication with the frontal camera, and that's from the instrument cluster, it passed and failed that test. So basically, this test is passing and failing, which makes me think that this is an intermittent type failure. And when you look at this next one, where we lost communications with the electronic brake control, it says it's a history code. In other words, it is somewhere in the past it had that failure, but it hasn't had that failure recently. That's a history code. So that's not current. So once again, this starts to make me think, by the way the scan tool is presenting the data, that this problem is intermittent. And it's not currently on the car. So we got to think about that, because when we're looking at a car, it has to have the problem presently for us to find the problem, okay? So now that we've looked at the codes, the next thing we want to do is we want to go down and we want to make sure that we can establish communications with this module. So we want to go to Module Diagnostics, and we want to go down to the camera, and this guy's right here. We're going to get into the camera. The first thing I want to do is I want to read the DTCs that the camera has. Now the camera is saying that it set a code for communications with the electronic brake control module. So that's the only code that it has. And again, the status, it's history, so it's not a current code. That's what that's telling me. So I want to make sure that we have communications and we can talk to this module. We got data, the DTCs from it, but what I really want to see is the data. So here, if we go into the data display, we can go down and we can start to see that we actually do have data, and we can see several things here to where it was learned successful and some of this other stuff. Now, what I'm interested in is this camera, because the shop I'm here doing the work for has replaced the camera. The camera had failed, and now they've put a camera in it, and it's setting a code for the electronic brake control not having communications, but it is a history code, but they're aware of that, and they want to make sure that they release this car where it's not going to have a problem. Obviously, anything with ADAS systems is safety critical. So we want to make sure that any of this type of circuitry and radar systems, camera systems, blind spot indicators is properly working before you release the vehicle. So basically, we can go down and we can see this, and we want to go back out, and I want to go ahead and I want to look at something else. So we want to turn the key back on so we keep communications with our scan tool here. We want to go to the indicator data, and the indicator data has said that we've dynamically calibrated this and the learn was successful. On GMs, you don't need target systems for the ADAS. You can just go drive these cars. So they'll dynamically learn just as you drive around in a certain configuration that they want you to drive in. And if that everything works, it's good. So this camera was actually able to go through a complete diagnostics and self-calibrate, which is again a safety critical system, which makes me think that this is a real intermittent problem for the communication failure we're going to need to see. We can communicate with this module. We know we have some communication failures here, and the failures are in history or they've passed and failed, which means that we're probably dealing with something that's intermittent, is what I'm thinking by what the scan tool data is displaying and telling me. What we need to do now is I want to get a wiring schematic out, and I want to get a scope, and I want to get up on the camera, and we want to make sure that our bus lines are okay. This should be CAN bus, it's high speed, so let's go ahead and take a look at what we have connected to this camera. Okay, so now what we need to do is we need to get a wiring diagram. So I brought up a wiring diagram and I found the front camera assembly. Now on that front camera assembly, the data or the comm lines that are connected, I have a high line and a low line, a high line and a low line. So there's 4 CAN wire systems that go into this one module. And then I have some other system that's coming off that's a front object detection sensor. And this wire comes down, so I need to know where it goes, and I'm going to follow it back. And we're going to come up here. And this guy comes across right here, and it comes up into my long-range radar, short-range radar, and short-range radar. So this is some type of comm line or communications that's saying what my object detection range is. So we'll want to look at that. But the comm lines, it's not saying we have an interruption in communication to any of the radars. It says that the EBC can't talk to the front camera. And the only comm lines I have on this diagram is showing that I have 2 CAN lines each. So there's 2 high CANs and 2 low CANs. So what I want to do is I want to go ahead and I want to get into this camera with a scope. So the scope is already up. We'll bring the scope up here, and then we're going to go ahead and get connected. So let's go ahead and get connected into the camera and then take a look at those signals. We're going to go ahead and connect the scope ground to the battery negative. We've back probed the scope into the CAN high and low lines. Now that we've got the wires connected into the CAN system, let's take a look at some of the data. First thing we're going to do is we're going to come over, and we've got 2 different time bases working here on the scope. This is the CAN high lines, and so is this. There's 2 highs and 2 lows. So let me show you. We're going to go ahead and we're going to change the time on the lower screen to the same as on the top. But now we're going to go ahead and we're going to uncover it. You can see how they're covered. That means that the 2 lines going in and coming out have the same data system. On some cars, you'll actually have two different CAN systems in the car. This is the same data, it's just going in, and it's using the camera as a path to bring the two other wires out. So this is the system, and we're going to go ahead and turn these guys off here, and we're going to keep that on. What we're looking for now is we're looking for the bias. This is the non-recessive bit. That's the 2.5 volts, or the active mode, and what I'm looking for is for it to pull the bottom of it to pull into the top, the high line, or the high line to pull down, or something to happen on the data. So we want to sort of watch this, and we want to see what's going to happen. And we can see that everything basically is looking okay, but when you're doing this in your bays, you're going to need to watch this for several minutes. The next thing you're going to need is to have the scan tool set up so we can see if we get a code set. So during the period of time that I'm watching this, did we have any code set? That will tell me if we have any problem in the bus structure. One of the CAN transceivers on the module that's having a problem, or this CAN transceiver for the camera having a problem. We've got to try to evaluate where our problem is. So now is what we need to do is let's take a look at the scan tool at the same time, and what we want to do is we want to turn the key on and off, and I want to cycle it. So let's do that. The scan tool has the DTC information for the car. The instrument panel has a code set for lost communications to this camera system. Again, it's passed and failed, passed and failed. It's not current, and it's a history code. When we go down to the front camera, it says that it's lost communications with the brake control module. So now if we go over, what I want to do is we want to go back to the modules, and we want to get a look at some of these. So we want to go to Module Diagnostics. We're going to go to the electronic brake control. I want to get the codes. We can see that it does not have a code set against the camera. So the brake isn't indicating it can't talk to the camera, but the camera is indicating it can't talk to this brake module. So I want to go to the instrument cluster, because the instrument cluster had a current code in it. So this says that it passed and failed, and passed and failed. It says it's not current, and it's a history code. So this is giving me an indication that I have some type of a code here with this. So what we want to do is we want to go ahead and we want to clear this code so we can see if it's going to come back. So now we don't have the code here, but we can go through and we can see if it's going to come back. At least we can see, while we're watching our scope and our data, do we have some problem? So one thing that I want to do is I want to go ahead and we want to cycle the ignition on and off. And when we do that, we're going to see the bus, and if I wait long enough, it will start to go to sleep, and then it will go offline. And that's okay. And then if we go ahead and we cycle it a few times and we bring it up and back, and it's what I'm trying to see is, do we set the code in any of these style conditions? So we're going to go ahead and we're going to let the bus go to sleep a couple of times, and then we're going to see if we get a code. So we'll be right back with you. Let's watch the scope and we'll see what's going to happen here. So there the bus goes. The bus is going to sleep now. So that's sleep mode right there for this type of car. Some of them drop below 1.7. Usually I expect 1.4 voltage for the basically the bias voltage that's on here, but this car has a different shutdown, and it does stay at the 2.5 in divisions. So now we've got this car asleep. So now is what we want to do is we want to go ahead and we want to get communication. So we're going to hit the ignition switch, and I want to refresh my rate. So I still have not set another code for the system. So now is what we want to do is we want to start the car up, and then we want to watch the scope and the scan tool once it's started, and we want to see if possibly it running is going to have any type of an issue there. So let's go ahead and start this thing back up, and we'll see if we get some kind of a code. So we've refreshed it, and we now have reset that code. So this code does not set until this engine is started and running. With the CAN bus up and running, and we saw no breakdown in the CAN bus from when we started it. Now when we did crank it over, the CAN bus gets pulled up. It goes high. So let me show you that. But that's normal. I don't think that's our problem, but I want to show you what you're going to see when you do this, okay? So let me go ahead and restart this. So we're going to start this up, and we can see where the starter had a very high draw. And we pulled this guy up some. So we can see that basically if we get the cursors, it moved almost a volt up. So that's a volt drop that it's moving the bus up with. Now that could be a problem, but I'm not going to look at that right now because I don't think that that's my issue. But that's some kind of a voltage drop off of the starter. When we have 1,500 amps or so, 1,000 amps rushing into the starter, we have this drop that's being seen in the bus structure. But I don't believe that that's my problem, but I definitely wanted to show you guys that so you can see it. So now is what we want to do is I need to go and we want to look at some wiring that goes to this camera head other than just the comm lines. So let's go ahead and we're going to take a look at the wiring diagrams. So we brought up the wiring diagram for the front view camera. This data is going to be under navigation. So that's going to be my blind spot detection, my radar, long range, short range, cameras, and so on. So here we found the windshield front view camera, and we can see we have a ground, we have a power, we have a lane departure signal, we have CAN high, CAN low, CAN high, CAN low. We have a serial data enable. So that's an enable wire that's going to be a power wire usually that's going to put power onto the system and it's going to wake it up. And then we have a lane departure signal. But look right here. This is pretty interesting, guys. This is a serial data line that was not shown in the vehicle communication interfaces. But that is a communication wire. That's LIN. What that means is that's CAN mid-speed. So CAN low is from 0 to 10 kilobits. 10 kilobits to 125 kilobits a second, that's CAN medium speed. 125 to 1 meg is CAN high speed. So this is a CAN, it's referred to as GM LAN, but this is actually a CAN medium speed. But that wire is not shown on your other diagram. So one of the things that we want to do is I'm going to move, since we already know that the CAN high and CAN low are on the same lines, in other words they go in and come out, the data is the same, I'm going to move two of my leads, and I want to move one to this data enable and I want to move one to this serial communications. So let's go ahead and do that and then take a look at the scope to see what's going on. So I've moved channel 3 and channel 4. Channel 3 is on the enable line and channel 4 is on the medium speed line, GM LAN. Okay, so we've back probed and we're into these new circuits. The new circuits we're in is this LAN line and this serial enable line. So those are two that we need to see. So now we're going to come over to the scope and we can see that I have the high line that's going to enable the data stream. that goes high when it comes up. I've got my CAN, and we've already been watching the CAN, and there's no failures that I can see as far as CAN goes, as far as packet formations. Mainly what we're watching when we're looking for CAN is we're looking at the recessive bit line, that's the bias voltage at 2.5 volts, and then we're looking at the packet formations of high and low. They all look fine. I've got a high line, but notice right here, this is LAN. There is no LAN on that system. This is a 0 to 5 volt signal on GM LAN. That's not present on this system. There's nothing here. Now I'm in a wire. I know I'm in the wire because my bias voltage from this scope would show me. In other words, when I've got an open circuit, this will turn red. So I'm in the wire, I just don't have any communications. So basically nothing's happening on this. So what I want to do is I want to go to the DLC off of pin 1, because pin 1 is where GM LAN is. So if I'm going to take a wire and I'm going to take it from pin 1, which goes from that wire and then goes into a bridge or a comb and then goes all over the car. And I just want to bring the wire up to here and I want to see what's going to happen. I want to get that wire back on communications to see if we're going to fix our problem or not. But this is definitely does not have the GM LAN going into this system. Now the really crazy thing is the wiring diagrams could really confuse you, because when you look at the data for the communications, that wire's not even in there. And when you come back and you look at the data, it just says that it goes to the COM lines, but it really doesn't show it. You go back to the communications structures for the wiring diagrams, those wires aren't even there. So that wire is there and it's present because I'm back probed and there's nothing on it. So let's go ahead and bridge that wire and see what's going to happen. I've back probed into the DLC pin 1 with this connection. Now we have the wire that's bridged from the DLC pin 1 to the forward view camera for the GM LAN line. We can see that we have a communication system that's occurring now. Before, there was no communications on the forward view camera. So let's take a look at this communications now. So basically, if we go in and we get a little bit of data, we can go in and we can see that these are packets of data. And each one of these contains high and lows. And these are zeros and ones, and these are Boolean code. And this is how the system is encoding the message. Well, these are messages that are shared on all the medium speed bus. The wire from this forward view camera is broken somewhere where it goes down to the comb. There's a comb where all these wires go together where I can disconnect each one, but somewhere between that camera and the LAN line, the bus, that wire is open. Now that we have data communication and we have data packs here, we can see these data packs. This is how that camera is communicating. It's sending messages down, and the other modules need some of this information, and the camera needs some of this information. So the camera is saying that it can't talk to the EBC and the dash. And the dash is coding this camera, but it did not code it until it was started. So in just an idle mode, even though the bus structure should be running, it never set a code. It only sets the code once the car is started, and then it runs for a few minutes, and then we're okay. So it sets the code. Now what's really confusing about this is you use a factory scan tool and you think that data is going to be great. But what the problem is even with the GM system, it's telling me that those codes are history codes, that those codes have passed and failed. Those codes could have never passed. The wire's broken. The wire's been broken since we got here. The wire was broken before. That's why we're working on the car, because it has a broken wire for the GM LAN. So that system is sort of confusing because it makes you think that that system is some type of an intermittent, and then you start to look at the wiring diagrams and you see that we have CAN lines. And the CAN system, as we've already talked about, the CAN looks okay. I didn't have LAN, but in the original wiring diagram, LAN isn't even shown. Now, whenever you guys do communications, you always got to be aware that there can be another wire to a module. Maybe it goes directly from your scan tool, so your scan tool talks to the module on a different wire. And that scan tool will get you confused because you're talking to the module, but the codes say that module can't talk on the bus. Well, the wire you're talking on is complete. The other communication wires can have a problem. Always be aware that there can be multiple communication wires. Always look through multiple wiring diagrams. I picked this car just so you guys can see how the wiring and how a scan tool can really get you confused. But if you take a logical approach, it's pretty simple. So basically, this wire's been broken. That's what's going on with the car. Now the shop is going to need to repair the wire. All I did was bridge this outside. So it's bridged outside, and we can prove that this is fix the car, and the car's been running for a while now. So we can look at our scan tool and we can refresh it, and we can see we're not setting codes. The reason that we were setting codes is because we had no GM LAN communications to the forward camera, and he can't transmit his data on these LAN packets. Now, one of the things that I want to show you guys is I want to show you a little bit more about LAN since we're here. So what we want to do is we want to come over here and we're going to start to record this, and we want to shut this guy off. Now is what we're going to see is we're going to see the LAN. This guy right here is going to have a 10.5 to an 11 volt message, and that's going to tell the system that it's ready to go to sleep, and then we're going to go to sleep. The enabling line here is enabling and turning on the CAN system. The LAN system is turned on by messaging within the system. So we actually have two different enables to wake up modules. One is done on the bus, and one is done with a hard wire where I have voltage that comes up. Here's the sleep call right here. Do you see how that's coming up at 10.5 volts, 11 volts? That put that bus to sleep, and now that bus is asleep. Now we're going to sleep. Now, right here, we can see that we started. That is enabling the CAN bus. Do you see that? When this high enabled the CAN bus and it came down, the CAN bus started to go to sleep. The GM LAN bus went to sleep by having a high voltage, and that is a message that's in there. So now we want to look at something else. We want to come in and we want to watch this when I restart the car. So we're going to wake it back up. Now we're awake. Now what I want to do is we want to take our zoom window and we want to come in on this. Do you see how this is a message? That's a wake up message. And you can see how we're about 10.5, 11 volts. This message woke the LAN up. Now do you see how when I came up with the green, green came up and the CAN high and low. This voltage is a voltage that's supplied to the module to wake it up. That got the CAN going. LAN is awakened and put to sleep, not by a voltage, but it's put to sleep by a message that's actually embedded. So this message right here tells it to wake up. This is a wake-up call. And the go to sleep call is very similar, but it's a different message pack. So that's a little bit about LAN. Now guys, I hope that you get the point of this, that you really need to look at the wiring diagrams, multiple diagrams, before we get started. Make sure that there's no other wires that I can communicate to a module, either through the scan tool or through some other system where that system is watching and we can be confused. The factory scan tool that we used, it sort of got us confused because it said that this is an intermittent problem or a history problem, it isn't current. This system never worked the whole time we worked on the car. That wire is open, that's why the car's here. The shop's going to fix the wire, we're going to deliver the car. If you follow some basic guidelines for communications, diagnostics, such as I've laid out, you too will have good troubleshooting in your base.